Today we're going to continue our work with volume measurements, liters and milliliters, and we're going to be introduced to a vertical number line, and we're going to see how that can help us solve problems as we advance towards word problems with liquid volume measurement. So without much further ado, let's go ahead and get started with vertical number lines. And we'll see where they come from too. Like we'll see why it's helpful to use a vertical number line, meaning it goes up and down rather than like right to left here in this first slide. So let's make a pretend container of water. So again, you'll have seen it. Wow, that is really quite bad. So let's try that again. Slightly better. I find it really hard to like look at my screen and draw on this at the same time. So bear with me here. So we have a container there. We'll say that this is right up at the top is 1 liter. And on the other side, we'll measure that in 1,000 milliliters. So then we'd have, working our way down 900 milliliters. I'm not going to label the milliliters here. Normally I would, but just in the essence, to save some time here, we'll skip that part. 800, 700, 600, 500. 500 is halfway to 1,000, so on this side I'll put, this is like 0.5 liters. 400, 300, 200, and 100. And I'll put on the bottom one, I'll put milliliters again. So this is, if I was filling this up with some water, forgive Mr. Brunel, who's colorblind. I'm not sure if I have the right color here or not, but if I was filling this up with some water, I would use that guide on the side to tell me how much I had, right? And I could see that it's at 300 milliliters. Well, this, measurement on the side with all these tick marks, that's just like a number line. It's just turned, straight up and down, vertical. And so that's really a good way to use, a good thing to use, good tool to use when we're solving problems involving liquid measure. We don't measure any liquid left to right. Like I don't, if you spilled it on the floor, it would just be flat and go out everywhere. You're not going to measure that. Whereas if it's in a cup, it goes up and down. You don't measure left to right with liquid. You measure how full something is, how high up it goes, which is why it's helpful to use a vertical number line. So a vertical number line essentially looks like this. Right? And then you'd have your 0 on the bottom, and your, in this case, we'll do tens this time. 10, 20, 30, 40, 50, 60, 70, 80, 90. I need a little bit more here, and 100. We'll call these milliliters again as well. And you could be asked to do things like place a dot on there. Say you were supposed to find 65 milliliters, you could do that. That's halfway between 60 and 70. Or you had to find 30, which is right here. You might have to compare these two, in which case you could say 65 minus 30 is 35. But it's a good visual representation of the numbers that you're measuring without having to draw the whole container that you're measuring them in. You can just look at the measurement side. This is essentially saying that I measured up to 30. So you didn't have to draw a whole cup and show that it was colored in up to 30. You just draw a number line and put a dot. It's the same basic thing as saying that it was full to 30 milliliters. You'll also notice when we do these that there will be other markings on here most of the time. So I'm putting the halfway marks on here. That shows that the fives, I counted by 10. So I'm going back and putting the fives in here. So 0, 5, 10, 15, 20, 25, 30, 35. In some cases, you'll even have the ones. I'm not sure I have room to squeeze them in here. No, I don't think I do, but 1, 2, 3, 4. I really don't. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't have room to squeeze them in, but you will have some problems where you have the ones on there as well, or there might be some problems where it's beneficial for you to draw the ones in. And just like we worked on with measuring time and with measuring weight, it's really, really important that you read these number lines accurately, whether it be a number line or if you're actually measuring liquid and you're looking at the how full something is. If you're looking at where the water or whatever liquid you're measuring stops, it's really important that you measure accurately, because if you're going to be asked to do word problems or real life problems um, based on that work, based on what you measure, then you need to make sure that you're accurate. So you saw how important that was when we were measuring kilograms and grams, where if you weren't accurate with your measurement, you couldn't possibly do the math right or correctly for the word problem. The same thing is true here. So if I had been asked to find 65 and I put it here, I'll do it in a different color, but if I had put it up here, I would have been way too far off where it actually should be. I'd be off by like 3 or 4 numbers. So that would cause me then to be wrong by 3 or 4 numbers when I went to a word problem based on that. We are going to move into word problems. I know we did a couple yesterday in our lesson. We are going to move forward and do an entire lesson on that tomorrow. But the basic point of today's lesson is making sure we understand this vertical number line and how it can assist us. Let's take one closer look at it. I'll do a zoomed in view because we can use it. We use a lot of ways, but we can use it to count from one number to another number and solve word problems that way. So we won't draw an entire one, but we'll call this like 20 milliliters, 30 milliliters, 40 milliliters, and 50 milliliters. And then I'm going to count by 2 from each of these. So 20, 22, I'll do that in a different color actually. 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. I chose 2 on purpose because I know that there are containers in our classroom that have measurements on them that are in group of 2. So it is something that you will see from time to time when you are measuring in the real world. So good to get in good habits with it now. Always check that too when you're looking at something. Don't assume just because there's a tick mark on there that it's measuring in ones. You should always look to make sure you know what it's actually measuring. I could then have a problem that asks me to do something like find, container A has a measurement of, container A has a measurement of 46. There we go. Finally get the right thing. That's container A. Container B has a measurement of 28. It's B, okay? And then we're going to compare. We're going to say how much bigger is A than B, or how much, not bigger, how much more volume is there in container A than B. And we're going to say to find difference, we subtract. And so on this, we could say, I could subtract 8 minus 6. I got tripped by my own problem here. So we went 2, 4, 6. Then I can go down another 10, minus 10, and then from there I can go minus 2. And if I add those up, 10 plus 6 plus 2 is 18. So the difference is 18 milliliters. I can confirm that. That needs to be capital L there by saying 46 minus 28. This is also great practice for us to work on our standard algorithm subtraction. If I have 6 of something, I cannot give 8 of it away. For example, if I have 6 pencils, I can't give you 8 of them. So I need to go over here and get a group of 10. So I break up my 40 and turn it into a 30 and a 10. And I add that 10 to the 6 to get 16. 16 minus 8 is 8. 30 minus 20 is 10. And I got 18 milliliters. Oh, my pen decided to stop working on me there. 18 milliliters once again. So I got it on both strategies there. So this just goes to show you that you can use this vertical number line just like you can use a horizontal one to solve problems. It's only vertical because it makes the most sense given what we're measuring here. I say it every day and I'll continue to say it every day. If you have questions, please ask them and I will do my best to answer them for you.